Hello and welcome back to Basics of Remote Sensing and Geographic Information System. My name is Vanessa Johnson, and today we will be doing data types and models. We are going to look at spatial data, concepts and sources. We're going to look at the data models. We're going to look at raster and vector in great detail today. So spatial data, what is spatial data? Spatial data is any type of data that directly or indirectly refers or references a specific geographical area or location. So spatial word comes from space. What exactly is there on that surface, that part or that place on the surface of the earth? So it is also called as geospatial data sometimes, or geographic information. So spatial data can also numerically represent a physical object in geographical coordinate system. Basically, it can tell you what exactly is there on the surface of the earth. That is what spatial data means. Moving forward, there are different models in spatial data. There is something called as the object based model, and then there is something called as the field based model. The object based model is a spatial feature and has some characteristics like spatial boundaries, application relevant and feature description, or attributes. If you remember from the last video that we did about that I spoke to you about attributes, spatial objects represent discrete features with well-defined or identifiable boundaries. For example, buildings, parks, forest lands, geomorphological boundaries, soil types, etc. So in this model, in object-based model, data can be obtained by field surveying method or laboratory methods. So you can get data by going to the field directly, or you can get data remotely sensed. Depending on the nature of the spatial objects, we may represent them as graphical elements of point, lines and polygons. So object based model, we can represent them in point, line and polygon. So if you remember, where is this coming from? This is coming from, is it coming from raster or is it coming from vector? So if you know the answer, please give it to me in the comments and I will continue further. So field-based models, field-based model is basically a spatial phenomena where real world features are, so real world features are not continuously there over the earth. They don't have a specific boundary. For example, if there's a river, the river doesn't just start and stop in a country. It can move or it can flow through countries. It can flow from one country to the other. So in such times, the field-based model is used, where data for spatial phenomena may be organized as fields which are obtained by direct or indirect sources. The source of direct data is from aerial photos, remote sensing imagery, scanning of hard copy maps and field investigations made at selected sample locations. So we can obtain or generate the data by using mathematical functions. I will not get much into detail about it, but DEM models can also be used. DEM, which is also known as digital elevation model. I will write it down here for you if you are inquisitive. Digital elevation model. This also can be used and it can be generated from topographic data and can be usually obtained by indirect measurement. So basically, field-based model is to do with features that are not bound or they don't have a specific boundary. Moving on. So this is a very good image to explain object-based and field-based models. So first, there is the real world, whatever is on the surface of the earth. Basically, in the object-based model, we are looking at different objects. We are looking at maybe a lake, or maybe a city, or maybe some settlement. So when we see that, we can take it into the vector model. So our vector model has PLP, So if you remember point, line and polygon, we can change or we can convert vector to raster and from raster to vector as well. So even if our object based model is not in PLP, that means in vector model, we can convert it into vector model, and we can make, at the end, we can make a spatial database. Now when we are looking at the real world, again, if we come back here as the first point, when we are looking at the real world again, and when we are looking towards the field based model, so in the field based model we have these features that are very large and extending beyond our boundaries. So when that is happening, we will need to take a sampling location, a small part of that feature. For example, if it is a huge river, we can take a part of that river and we can get some information from that. We can create an image grid matrix. I am again not going into the details of that. We can get this data as raster. Mostly we get this as raster because these are images, or this is data that is that we are receiving through remotely sensed data. So usually it is in raster data set, and then again we can convert it into raster or vector, however we feel like. So moving on, then there is non-spatial data. So previously we did spatial data. In spatial data we had object based and field based. So spatial data, again, to reiterate, to revise, is whatever is on the surface of the earth. Now non-spatial data is data that is known as attribute or characteristic data. This is very, 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 very important. So it consists of the characteristics of what? It consists of the characteristics of the spatial features. So non-spatial data is simply giving you information. Non-spatial data is giving you information about the spatial data. So these non-spatial data, for example, I spoke to you about a river in spatial data. So that river may have a name, yes, it will have a perimeter, it will have area, it will have the type of water, the purity of the water, the amount of sedimentation in the water, amount of chemicals in the water. There can be multiple things and multiple characteristics. There can be a lot of data that I can receive of the spatial data. So that data that I am giving of the spatial data is called as non-spatial data. So this is not to do with, it is not giving you information about the space, but it is giving you it is giving you information about that particular place in terms of numerical data and in terms of its characteristics. So it can give you a lot of data about that place. Now spatial data models, again, since we are talking about spatial and non-spatial, please do not get confused between them. Spatial data again is to do with what is on the surface of the earth. So when we are talking about the surface of the earth, we have the raster data model and the vector data model. First, to do with raster. Raster is a grid, regular grid of cells. It is a grid, this entire grid that you see, and it has these small squares which are called as cells. These cells are in a very particular sequence. So these cells are in rows and columns. So my horizontal will be rows and vertically these are called columns. These are cells and it is a grid of cells. Okay, so this if I want to show a line on raster has cells. Now I cannot show a line exactly, so my line will be this way. This will be my line when I am looking at raster. This is a point and this is a polygons. So whenever you're looking at raster data, they are in cells, or another great word to use is pixels. So it's a grid of cells or pixels. Now in spatial data model itself, we have vector data. So again, to reiterate, vector data has point, lines and polygons. So it is PLP. Please remember PLP. It can also have a S at the end, PLPS. So S stands for surface. As we are doing basics, you don't really need to know about surface right now, but the main thing that you must remember is vector has point, line and polygon, and raster has cells. So when I'm talking about point, line and polygon, you can see this is my line, very easy. This is a single point and this is my polygon. So it's very easy for you to understand. This is discrete in nature. That means it gives you the exact image or exact feature, but this cannot be found or cannot be so when you take a picture, you do not get the picture in vector data. Whenever an image is taken, whenever an image is clicked, I am talking about remotely sensed images, these images are always in raster data. Raster data again is the grid of cells. That raster data can be made into a vector data model. That means I can sit and digitize my grids and the cells and all that we had into point, lines and polygons according to how I want it. So when you are learning GIS, when you are actually starting to digitize, you will see a screen like this, and you can make the map from raster to vector. So again, this is raster. Raster is a group or grid of cells and pixels. So you must remember this at all times. Group or grids of cells and pixels. You see this entire grid, and in this you have small squares. These squares are called cells or pixels. In my raster data, this would be a point. This whole thing would be a line, if you can see the way that it is made, and this whole thing would be a polygon. Okay, so in vector now I have PLP. PLP stands for point, line and polygon. So again, this is my point, this is my line, and this is my polygon. Very simple examples have been given to you here. A point can be a well, it can be a tower, it can be a temple, it can be a hospital. My roads and pipelines will be line data, and polygon data can be lakes, it can be agricultural areas, it can be states, it can be districts, it can be boundary of a country. All of that is also coming under vector and polygon. Now we will move on to non-spatial data model. So what is non-spatial data doing? Non-spatial data is giving us information about what? Information about spatial data. Whatever is on the face of the earth, we are getting characteristic information. We are getting quantitative and qualitative data. Quantity and quality. We are getting both of these types of data when we are looking at non-spatial data. So in non-spatial data, we have hierarchical data, we have network data, we have relational data, and we have object-oriented data. There is I will be explaining in terms of with the help of images, which will help you understand better. You can read what is on the screen, you can take a screenshot if you like, and you can understand better with the notes as well. Again, if you want the notes, please do comment in the section below, and I will be sending you the notes online. Okay, so this is an example of all 4 data types, very easy to understand. So relational, when you look at relational, it is more tabular format. It's a table format. For example, when we have to when you take admission in a college, or when you take admission in a university, so you have to give in some details. So you will give in your name, your age, your previous class, you will give in information about your address, you will give in maybe the subjects that you like, right? So now this data, or the same data that you're giving, excuse me, okay, sorry, so the same data that you are giving has been given by another 100 people. So I have, say, 1 to 100 people here. Your data has to be put into some model in order for me to understand how many people and what subjects you have. So that is called a relational model, where I am using some relation and I am using a tabular format to understand what type of data there is. Okay, so there are, so here in relational data model, the values are atomic. Each and every single row is unique. Each and every person here is unique, right? There are 100 students. Even if 2 students have the same name, they are different from each other. They're not the same person, they are unique, right? So each row is unique. The sequence of rows is insignificant. So I don't care, there can be 100 students, there can be 1,000 students, there can be 10,000 students. What is going to be there, that the values are all going to be different. Even if you have the same name, you will not be the same person. So each person is unique. Each column also has a unique name. So I gave here name as name, age, class, address, and subject that you have selected. So even the columns are unique, and even my rows here are unique. So each person is different, and also their details are different. Okay, so this is the relational model. This is more tabular, so in terms of a table. Then we will move on to network. So in a network, you will see that everything is connected to each other. So that is why we even call it the internet. Why are we calling it the internet? Because each and everything is connected to each and every other thing. So for example, I am teaching a class of 50 students. Because I have maybe a WhatsApp group with them, I can send information, I can send notes, I can send images on that group, and it will go to 50 different people in a single second, right? So that is network. That is how strong my network is. Now these 50 people, once they receive the message that I have sent them, they can send it to another 50 people, right? So everybody is simply connected to the other person, or the connected to another network. So this is called the network model, where everything or everybody is connected to each other. Then we have the hierarchical model. Hierarchical model is very, very simple. It is basically giving you a hierarchy. It is a tree structure also. Let me just write here network, and this is a tree structure, tree-like structure. Why? Because there is a main entity, and then there are things that are joined to it. So for example, I am sure you must have made this type of diagram when you were in school. So the hierarchy of maybe institution. So since we're talking about an educational institution, if I say who's at the top of the institution, so the person at the top of the institution can be the trustee, or can be the principal, right? So below the principal or below the trustee would be the vice principal. Below the vice principal, so for example, there is a principal here, we have the vice principal, right? We are talking about simple school or an educational institution, below the vice principal we will have deans of various college, of the college. So there will be a dean. Below the dean we will have the different head of departments, right? Below the head of departments we will have the teachers. Below the teachers we will have the non-teaching staff, or the people who are helping out. And below the non-teaching staff we will have the students who are studying, right? So this is a hierarchical model where you are giving a hierarchy and a parent-child relationship. So for example, even in your family you will see that there's a hierarchy. So like for example, you have your great grandparents, then you have your grandparents, then you have your parents, and then you are there. And then as you go along in the future, you will have your own family. So you will have your children will have more children, right? And so it continues. So this is called a hierarchical model. Then we have the object oriented database model. So in the object oriented database model, we are using DBMS here. So DBMS stands for database management system. Management system. So this is basically called DBMS. So here you have different objects, okay, and each object has different attributes, and they have a lot of information inside it. For example, if I have a map again of India, so I have a map of India. In that I have different objects. My objects can be states of India, right? So inside, if I click on India, I will get the names of the states. Then if I click on the states, those states will have more attributes to it. So what is attribute data? If you go back to the previous video, you will know that attribute data is giving you more information about that particular area or place. So if I click on Jammu and Kashmir, if I click on Kolkata, if I click on West Bengal, I will get a lot of information of that state. So in that state we will have districts, we will have different territories, we will have rivers, we will have lakes, we will have number of people, we will have so much information. So all of that is coming into my attributes, and this is a lot of data, right? So this data has to be managed. That is why in object oriented database model DBMS is used, where they are trying to manage this huge data with the help of programming languages. So here there are a lot of programming languages that are used. Okay, moving forward. We've come to the end of the session here. So I hope you have understood. If you have any doubts, any questions, please write it in the comments, and I will try my level best to answer all your queries. If you want me to cover something more in detail, you can ask for that as well, and I will see you in the next video. Thank you so much. See you next time.